Hello everyone. Good afternoon. And today, my topic, like Dr. Parvati mentioned, going to be about Society 5.0 and the future of factories. We're just looking at some ways that we at Omron use the technologies to transform toward a people-centric workplaces. Let me start off the session with a brief introduction to Omron itself. Omron is divided into four different business domains: industrial automation business, healthcare, social systems, and electronic and mechanical components business. Omron is an 86-year-old with full of innovations and more than 9,000 patents spanning across 117 countries, over 35,000 employees, all of us sharing the same mission to improve lives and contribute to a better society. This is our corporate motto since the beginning for a company, which has guided us through all this time. So before I dive into today's topic, I want to show you Omron's scenic theory of predicting the future through the interrelationship of science, technology, and society. This was conceptualized by our founder, Kazuma Tatesi, exactly half a century back. So the scenic theory stands for seed innovation to need impetus cyclic evolution. According to the scenic theory, science, technology, and society share a cyclic relationship, mutually impacting and influencing each other in two distinct ways. In one direction, the technologies that IT to advance. In the other directions, social needs spur new technological development and expectations for new scientific advancement. As you can see on the top corner, it is going to trigger each other to keep developing and progressing in the society. According to scenic theory, we are currently in an optimization society. This is the last and final phase of industrialized society, which leads us into autonomous society by 2025. AI and Industry 4.0 play a key role in transforming our current society towards Society 5.0, which in Omron's terms called a natural society. In the optimization society, people and machines will find an ideal level of harmony. At Omron, have seen the evolution of automation technology to change the relationship between humans, machines, from replacement to collaboration and harmony, to make machines bring out the best capability of human creativity. If you look at the progression of society and technology, we never alone. Industry 1.0, which is steam-powered, agrarian society time, and in Industry 2.0, electric power, which sparked the industry society. Industry 3.0, computer internet, sparked the digital society. The Industry 4.0 that we all are seriously into is the lead into the Society 5.0. With the advent of internet, we all know that we are left with a humongous amount of data. With the Industry 4.0, we now have device method to systematically enable the data collection, data generation, and data utilization. Analytics, AI, connectivity have revolutionized the way we analyze and use the data in extremely creative ways to enhance individual machines' capability and productivity, thereby creating a wave of value creation through connection and collaboration. Now we are looking to build on this platform to human-centric and solution-oriented systems for the future generations to come. While we progress towards Society 5.0 and the future of technologies, there are obvious problems we need to address. The problem which are relating to environment, society, and technology need to be addressed sustainably. According to Omron sustainability policy, we build key practices. We are committed to sustainably increasing our long-term value by putting our mission and values into practice. In year 2017, Omron set key sustainable issues based on sustainability policy, which are made up of two main areas. First, the issues to solve through businesses by responding to social needs. The second one is to address, to build a strong platform to address how we can create a society that can solve through business, to create a society that is able to solve the problems through social needs. Today, we will be primarily looking into the first item, which is issues to solve through business. So in this regard, Omron has set a goals to achieve through business, and it selected key businesses to focus on. First one is social solutions. This is to contribute to create a stress-free, safe, comfortable urban traffic system, contribute to sustainable society by promoting the use of renewable energy. The second one is healthcare, contribute to healthy and comfortable lives for people around the world to achieve zero cerebrovascular, cardiovascular events, zero asthma attacks. So today our focus is industrial automation. This is to contribute to economic growth through social productivity improvement to enrich people around the world. If you look at the industrial automation, Omron has identified two key issues in the upcoming times. One is shrinking labor force is an issue in global manufacturing process. Two, shortage of skilled workforce on production floor and requirements of increasingly advanced and diversifying manufacturing processes. Like Dr. Parvati mentioned, this is to address the sustainable development goal number 9, industry, innovation, and infrastructure. To solve these identified issues of industrial automation, Omron strives to enable manufacturers around the world to adapt Industry 4.0 technologies to create a smart manufacturing ecosystem. Smart factories will be at the center of smart manufacturing ecosystem and run by advanced manufacturing systems and equipped with sensors to ensure zero default, reactivity to events, traceability, and predictability. Robots will ensure real-time autonomy and productivity while collaboratively working with humans. Autonomous vehicles, on the other hand, increase the flexibility of smart factories and optimize the flow of materials. Nanotechnology create smart value-added services and become a key differentiator between manufacturers. Additive manufacturing will help to scrap elimination, mass customization, and rapid prototyping. Industrial IoT, on the other hand, will take care of object tracking, real-time data capture, and find ways to reduce wastages. With the data-driven smart factory in the center, the smart manufacturing ecosystem will be connected to sustainable resources of future. And Logistic 4.0 will enable fully integrated supply chain, interconnected systems, perfect coordination to ensure on-time material supply. Using these smart factories, we will produce personalized manufacturing services to clients. This will be an on-demand manufacturing with mass production efficiency, and that it will perfectly match what customer requires. It will have a flexibility to cater high-mix, low-volume production requirements. Collected big data, on the other hand, will be analyzed and taken to key insights to make sense of the complex data, enable human creativity, and create a collaborative manufacturing opportunities. Cybersecurity, on the other hand, will provide stronger protection for the internet connected manufacturing systems globally. So we are moving away from our conventional way of manufacturing, and then our key focuses are changing. Thus, the key characteristic of future factories will be changing too. Factories will become hyper-connected, self-optimizing, and self-learning. Current mass manufacturing mindset will change to design to manufacture and IP creation. Convergence of technologies such as cloud, analytics, blockchain, and collaborative robots with 3D printing will transform the data-driven manufacturing. AI, machine learning will predict the supply chain issues to make alternate schedules to meet the demands. Customer and market behavior analysis will enable enterprise to accurately forecast and produce for tomorrow. Getting to the ideal future factory will have its own challenges, inclusive of previously mentioned shortage of skills and other issues like legacy machines which are producing vital data, but gathering and sharing the data is extremely challenging. If you see the industry, there are many such factories that is churning out products and doing critical manufacturing. They have a lot of legacy machines which is like 25 years old. Getting the data out of them to see key insight is going to be a problem. High mix, low volume consumer demands. Even though we are gearing up to meet the high mix, low volume demands, but as we know, it can get really complex in terms of customization and what different kind of customers would expect a manufacturer to produce. And then we have already noted that complexity of supply chain in recent times due to geopolitical events can be rather difficult to manage. So to address these challenges and rapidly bring Industry 4.0 and the smart manufacturing to customers around the world, Omron has devised a unique approach called IAutomation or innovative automation. Our IAutomation concept, designed to enable manufacturers to rapidly adapt and environmental changes in the most productive. Core principles of IAutomation concept are to help our customers digitalize and reorganize their manufacturing, successfully address the market, while at the same time serving the business goals. Let's look at the three I's that is under the IAutomation concept. The first one is integrated technology, which involves seamless integration of technologies through advanced control, aiding the market makers to pursue maximization of machine performance and accuracy. Intelligent aspect of this IAutomation encompassing solutions to make manufacturing smarter by utilizing information technology. It aims creation of additional value to shop floor by enabling the makers to collect, visualize, and analyze data. Interactive element of IAutomation help manufacturers achieve the right harmony between humans and machines, leading the creation of those manufacturing sites where machines adapt to human needs and work together to enhance productivity. With that understanding, Omron has extensive lines of control components and equipments ranging from vision sensors and other input devices to various controllers and output devices such as servo motors, as well as a range of safety devices and industrial robots. By combining these devices via software, Omron has developed a variety of unique and highly effective automation solutions for manufacturers worldwide. Let's take a look at some of these applications and services created by Omron to address some of the gaps towards smart manufacturing. The first one is an integrated solution. The automation process of such as assembly, inspection, and transportation that very much rely on people's experience and senses. Labor shortage and increasing labor cost of recent years triggered the need for automation of such tasks. However, to automate the bin picking of bulk parts performed by humans in an assembly process, robots need to be equipped with human-like eyes. And that requires high-speed 3D vision sensing technology capable of instantly recognizing the position and orientation of the parts. To this end, both of the two component technologies, 3D measurements to generate 3D images of a shape, and 3D recognition to recognize the position and orientation of the target object, need to be faster. Omron has created a high-speed 3D vision sensing technology capable of instantly recognizing the position and orientation of the parts, collaborative robots to work in harmony with humans. Let's take a look at a small video clip of this, of how this is being applied. Okay, so if you could see on the screen, the robot managed to, or the 3D vision system managed to capture a part in half a second, which in manufacturing standard, it's reasonable throughput for such a system. So the second one is an intelligent defect detection using AI. particularly, the first component is of this, the AI scratch defect filter. The AI scratch defect filter learns by means of images in which human inspectors notice defects, whereas the previous conventional methods found the unexpected size, shape, and color of a particular defect to be barrier to automation. AI successfully extract abnormalities by judging their features without definition. The learned data facilitates defect detection process surfaces and other uneven backgrounds that previously posed an extreme challenge. The second part of the intelligent component is of the defect detection algorithm is the AI fine matching tool. Sensory inspection requires a certain tolerance and variation that does not pass a certain threshold. If you look at the image here, you can see there are some slight variations in the captured image. And that not necessarily means it's a reject. If you put this through a conventional system, as you see it on the left, it is going to say, this is not what I thought to find. The threshold is not met, or it's out of the threshold, so it's a reject. So determining what variations are acceptable is a key capability of expert human inspectors and poses a challenge for automated inspection systems. But AI fine matching identifies the features that is not included in good products as a defect. AI learns the images of good products with variations and generates an AI model. Every time an inspection is carried out, AI reconstructs a model that is assumed to be a good product and extract the difference between reconstructed good product image and capture the image to compare and identify that is within the learned data as a good or a bad product. If you look at the images on the right, there's a comparison between a captured image, non-AI vision response, and then AI fine matching response. So this product is an LED die. It's being wire bonded. So if you see there's a foreign material, both non-AI vision and AI fine matching is detecting it as a faulty product. And obviously, if you can see the mark that is captured by AI non-AI vision, it captures a lot more details than just the error or the defective area. But in the second one, if you look at it, a different die position. So in a real life scenario, for an LED die being in a different die position does not make much difference in terms of illumination. An expert operator would know that, but not the non-AI vision. Once we train the AI fine matching, it is able to look at these variations to decide whether it is within the acceptable range or not. The last one is the same. The AI fine matching is able to tolerate the minor variations and different die position rather than outright rejecting it. So it might look simple, but in the real applications, if we are trying to implement non-AI vision, we will end up having a lot of rejects or faulty parts getting into a good product batch, which we do not want. I just want to take a moment to explain the defect detection model training. And I'm sure a lot of participants here today are data science and AI background. So doing this is not a big deal. There's a lot of libraries and open source tools that we can put the images through to train them, and we are good to go. But the problem here is it has to be made in a way that is lightweight, able to run in an industrial system. On top of that, it should be able to meet the throughput requirements. It cannot be too complex. There is another aspect of creating such a product is that you should be able to let an engineer or a technical person at customer side who is not an AI expert. So by following these simple UI and 3 steps, user is able to collect good product image and defect product image. It's in the range of hundreds and 200 images per set. And they can it through the UI and then create the AI model, which he can try it out on the same set of images or in another set of images to understand how the classification works. If in case he found out to be certain parts or certain defects are not treated in a way that he wants, he can choose to collect a little bit more samples on that and then train it, and it is good to go. So the next part of the presentation or the next part of the IAutomation concept is an interactive element of it, creating a harmony between humans and machines using a cell line control system. We used a combination of AI, IoT, and 5G network to perform AI analysis of the workers' data. The human recognition system automatically recognizes the worker's movement, detects incorrect and wasteful motions, and feed them back to the operator to help them correct movements at the early stage of the training. So if you see there is a picture illustration at the top, a beginner and a skilled worker. So the way that you are taking apart and how you're assembling, where you're keeping your tools matters in terms of how fast you can complete your job, and that translate into the proficiency of your work. So this interactive feedback at the early ages of training improve the rate at which the operator gains expertise in a specific process. Let me play a short video to see how this is put in practice. Okay, so that's all for the applications. Let's look at a service that Omron has created in relations to closing the gap between these smart manufacturing and the current state of customers. I built a co-creation business model for innovation. Sorry, just give me a moment. I was just looking at the chat. Okay, so I built this co-creation service by which we deliver innovative automation. It's centered on a data utilization to customers and continuously innovate manufacturing side by evolving together. So the key idea is to work with the customer who has the abundance of data and help them understand if the data is sufficient or if the data need to be collected further to solve a specific problem that they have. So what Omron does is that go into customer facility, evaluate what is there, talk to the experts in terms of the process, and initiate a data collection. Use the data to create visualizations and analyze to look for key insights. Obviously, as it's mentioned as a co-creation, because we definitely cannot understand the 100% process of what customer is doing, but we have the core technical knowledge. Once we have that, we can discuss with them to how to feedback that particular information back into their process or automation controllers to create a perfect control so as to solve the problem and optimize the process that they're doing. So there are multiple areas of co-creation that is covered under this IBELT. One is production control, quality control, equipment efficiency, and energy efficiency. And it's been done in 3 different stages, as I mentioned previously. For each of these, we will do a visualization with the customer, we analyze, and make a control program for them to efficiently control whatever the objective they are trying to achieve. In production control, often it is a shortened production lead time. In quality control, it is often to improve the yield rate. In equipment efficiency, it is to reduce big losses. Energy efficiency, to increase the energy consumption in their plant or in a machine. So with this, I'm nearing to the end of my explanation on this part. In Omron, we believe in collaboration and co-creation of technologies and solutions. As you have seen on my presentations above, we have a set of frameworks and then technologies to work with our customers to solve issues through IAutomation. But we equally value the opportunity to collaborate and co-create with industry partners, startups, and academic institutions. In the past, we have leveraged on niche expertise such as IoT and augmented reality of startups to create value-adding solutions internally and to customers externally. For instance, we have worked with a startup in Singapore to create IoT dashboards. And then we have worked with a company in India to create an augmented reality app for our salespeople to use that and then get to the solution building part quickly. Similarly, we also have worked with the local institutions in Singapore to create an advanced manufacturing center, so showcase the smart manufacturing capabilities. This will be used to educate and train students who are our future generations. Today, I would like to extend our warm invitation to all of you to join us in this journey to collaborate and perfect the optimization society and leap into the future. Society 5.0 is going to be an informed society, well connected and involved with all of us, and it will be responsible. A society where anyone can exercise creativity to pursue diverse values free from existing frameworks and constraints. Society 5.0 is not something to come, but to co-create. Main element of the society is not technology, but it's human. It is going to be human-centric. It is a society realized by people who with diverse values and with diverse imagination and creativity. With that, I'm coming to the end of my presentation. I would like to take this opportunity to thank Indo Data Week and organizer to this marvelous job of taking up the task to tackle SDGs via data and AI, and inviting us to participate in this noble goal. When I thought of this event and objectives, a quote came to my mind. When you want to achieve something, when you want something, all the universe conspires in helping you to achieve it. It's from The Alchemist. So I think all of us here have the sustainable development goals, and then the goodness of that for the future generation is ingrained in our life. So when we keep that in mind and reflect in our daily action, we will achieve the goals in due time. And thank you for your time. Thank you for listening to me, and stay safe. Thank you.